This is going to be really weird because we're going to record a video of me teaching from a year ago, but I'm in the video again. Oh, this will be fun. All right, let's see how it goes.
All right, guys. Let me get my computer set up here. A lot of Section 2.7 is Algebra 2. This should be extremely familiar to you. Solving equations in one variable.
Oh, yeah.
You've got to be able to get rid of denominators. So you've got to be mindful that what you're looking at is this. We're going to ask questions like, you got to be able to factor your denominators. This one happens to be in factored form. I mean, we can do things like, what's this denominator missing? It's missing an x. What's this denominator missing? It's missing an x. And then we can take this entire equation and multiply it by the common denominator, which is x. And you know that if you multiply something by that common denominator, it's going to eliminate all those denominators.
Oh, yeah.
So we really have x squared plus 3 equals 4x.
Oh, that's simple.
So this looks a lot easier than the original problem you were working on, but that's all it is, truthfully. And so you can push this term to the other side. All of this is basic Algebra 2 type stuff. Factor it if it does factor.
Factoring.
And so you can say things like, well, x is equal to 3 or 1. Now, the truth of the matter is, you better check. 3 plus 3 over 3, does that equal 4? The answer is yes. And 1 plus 3 over 1, does that also equal 4? And the answer, of course, is they both are, right? Check on both accounts. So x equals 3 or 1. That's a pretty straightforward Algebra 2 type questions. So
Remember that when in Algebra 2, we looked for extraneous solutions. We could create a solution on accident, doing all the math correctly, and the word extra is inside the word extraneous. So we had to plug it back in to check and see if it really was a solution. Let me listen to myself again.
This, common denominators right here. The first one is missing, obviously 0. I don't even know why I'm wasting my time thinking about this. I know it's over 1. You can look at this and you can say, okay, what's this denominator missing? This denominator is missing in x minus 4. You got to realize that x minus 4 and x are separate things.
Definitely.
And so if you were to multiply the entire thing by the common denominator x minus 4, right? This would cancel with all your denominators, giving you x squared, because I'm going to distribute that.
Yep.
Minus 4x plus 1 equals 0. Now, this doesn't factor so nicely, so got to hit it with the quadratic formula.
Or I could complete the square.
What's my discriminant? My discriminant,
nobody's going to do that.
Squared
Going to go with the quadratic
minus
formula.
4 times a times
my face is
c.
in the way.
Okay, so that is 16 minus 4 or 12. Okay, so if we've got our discriminant, then the rest of the quadratic formula would be the opposite of b plus or minus the square root of the discriminant all over 2 times a. In this case, that would be 4 over 2 plus or minus. Remember that you can simplify square root of 12 into the square root of 4 and the square root of 3, which would be 2 radical 3 over 2. And so then we can simplify this to our final answer, which would be 2 plus or minus radical 3. Okay?
All right, now, did you see that I split that up into 2 different fractions? You know why I did that? Because a lot of you, let me see if I can draw on here. A lot of you, got to choose the right tool, can simplify that. And a lot of you can simplify that. But for some reason, when we put it together, let's say I had 4 plus or minus 2 radical 3 all over 2. You guys do stuff like this, and you make it 2 plus 2 radical 3. Well, that's illegal. That's why I split it into 2, so that you could get the 2 from the original fraction, right, that part, and then the 2's cancel out there, leaving the plus and minus radical 3. I apologize for yawning. I know you hate it when I do so. Clear.
And those two solutions are the solutions to your question. Okay, eliminating extraneous solution. Remember we talked about this extraneous solution. You have the word extra in there. In other words, you do all the math correctly, but it doesn't end up giving you a good result. When you factor this denominator here, it factors into x minus 1 and x minus 3. So to continue here, you would, the first, here, let me zoom in a little bit more here. So what's the first one missing? Well, the first one's missing an x minus 3, top and bottom. Okay. And what's the second one missing? It's missing an x minus 1, which I'm going to write below because I'm running out of room.
Yes, you are.
So if you multiply the entire thing by that common denominator, x minus 1 times x minus 3, then, of course, we're going to get a lot of things to cancel out. Those will cancel with those, will cancel with those, will cancel with these. Sorry, missed my x minus 1 there. And we can then distribute this to get your 2x squared minus 6x plus, and then you got this one right here, x minus 1 equals 2. Okay, and you can continue down the page here, you know, 2x squared minus 5x. Bringing this to the other side, you got a minus 3 equals 0. Now take your favorite pick if you want to factor this. What you should be able to do, I'm pretty sure we can do this one. The Berry method would be my choice, unless you're just a guessing checker, which that's what they made me do when I was in high school.
Yeah, it was horrible.
For those of you who haven't need a refresher, so we multiply that times the end. This is going to look like a double magic trick, and then we factor it normally. And we would have minus 6 and plus 1. And then back in front of both of the x's comes back our magical 2 that disappeared. Okay. And then we look for any GCFs we can pull out and get rid of. So we can pull out a 2 out of this first one. And the second one doesn't have a GCF that can be removed. So you have successfully factored the original problem, right? So this and this are the same. That's the Berry method. Looks like a kind of a double magic trick went on there.
It does.
Then we can look at this and say, well, okay, x minus 3 equals 0, 2x plus 1 equals 0, and we can come up with x equals 3, and then we can...
Okay, now, I should have stopped it a little bit earlier, because you guys are grown up enough to know this is the Berry method has a nasty algebra proof that I would not want any of you really to try to sift through. If you graphed this parabola, and this parabola, they would not have the same x-intercepts. Okay? And what did they do down here? They actually did a transformation. They actually did a horizontal shrink on those two values right there. And when they replaced the x's. Now, by doing that, they ended up transforming it into something which is not equal to the red one. It has the exact same x-intercepts as the original one does. So by doing this little magic trick thing where you're, you know, this one down here isn't the same as the one up above, but by getting rid of that GCF that's hiding inside of the 2x minus 6, you actually got it to be factored, to have the right factors for the original parabola. It's weird, but you would actually see it better graphing than you would by doing the algebra.
And come up with our other one, x equals negative 1/2. Now, are those both really good solutions here?
Whoa.
Well, you can see from the original problem that 3 is going to be a problem. Why? Because it shows up in the denominator.
Yeah.
In other words, it's not even possible to plug 3 in because it's not, it creates a false situation. So this
True.
one is my extraneous solution, and this one is the only good solution.
Will there always be an extraneous solution? No. We could actually have something with all extraneous solutions if we wanted to, but that would be weird.
Now, to be fair, you would really technically need to go back to the original problem and type it all in, okay, to see what you get, you know. So that's the first fraction, and then you're going to plus 1 over, this is really tedious. Good thing we could use a calculator to do this. And then it's got to equal this last one, which I've completely run out of room to
You did.
show that work.
You ran out of room.
So you would need to type that on a
Seriously.
calculator to double check that. Because if that one ends up being extraneous, then there'd be no solution to this whole question.
Yeah.
Which I'm pretty sure I can double check that. That was
Faster. Double check it faster.
An example.
You're looking in the book, aren't you?
World.
Man, you should have done that ahead of time.
Yeah, 2.7 example 3. That one ended up being negative 1/2.
Yeah. Okay, fine.
Okay, we'll move on to the next one. Okay, so getting a little bit redundant here, you know, looking for GCFs so I can pull that out. What's this first one missing that the other one has? It's missing an x plus 2, top and bottom.
Tired. Been a long week so far.
And what's this one missing that the other one has? It's missing an x, top and bottom. And this one has everything that it needs. So we're good to go. Then we can multiply the entire thing by that common denominator, x times x plus 2. And, of course, as we've seen other things in the past, we'll get rid of all those denominators, right? So we've got a little bit of foiling to do there. X squared, 2x and minus 3x. So that would be a negative
Negative x.
1x. And then I'm just doing all this foiling stuff in my head.
Ooh, dangerous. Should have used a box.
Plus 3x plus 6. Right?
Got all
You
lazy
your 3x
on us.
and your 6 right there equals 0. So broken record. Seems like we're doing a lot of this. Ooh, the minus 6 and the plus 6 cancel out. And so that's x times x plus 2.
Oh, factor it. Nice.
Equals 0. And let's see here. Well, so we'd get x equals 0 here. And we get x plus 2 equals 0, which is x equals negative 2. Wait a second. Both of those are actually restrictions on the problem. You can see
What?
we have a factor of x and x plus 2 in the denominators up here.
What?
That means both of these are extraneous, right? That's
Then what's the answer?
extraneous, and that's extraneous. So what does that mean? No solution.
No solution.
Right? Because the only two possible answers did not work.
No solution. It's like being in a science class with an empty beaker.
Okay, so nice trip down memory lane. Finally get to a question that's
Speaking of chemistry.
not something you have done lots and lots of, but we have seen things like this in the past. How much pure acid, okay, must be added to 50 milliliters of 35%. Okay, now pure acid, that's 100%, right? 100%. Now, we don't know how much that is, so what we're going to do is we're going to classify that as X. Okay, you'll notice that the coefficient that I chose for this was a 1.
And 1 happens to be the decimal version of 100%.
1x. Okay, now remember, don't write that down at parties because people will laugh at you.
True.
That's 100% of whatever this pure acid solution is. But to that, we're going to add 35% of a 50 milliliter solution. And what we want is a 75% solution.
Where is that
now,
moving?
That's 75% of these milliliters plus these milliliters.
Okay, all right.
So here's your equation that you're trying to solve.
Now, so this is another way to do it. I don't like this version, but this is what the book says. So if you see this in Math Excel, so they took the total number of, acid from this particular part of the solution, and then they took the 35% of the 50, that's 17.5. So this numerator represents your acid. This denominator represents the total amount of liquid. If you take, I mean, just like if you on your test, if you took the total number that you got right over the total number of questions, and you got a 75% on the test, that's what's going on here. But the first thing you're going to do in setting it up like this is cross multiply. Guess what? You are right back to where you were. So I don't see any advantage to that. It doesn't make sense to me. All right, let's listen to me talk. Maybe.
Not a real big challenge. The biggest challenge was for you to change it from the science story problem into something that you could work with. So 0.75x plus, is that going to be 37.5? Am I right there? 50 times 0.75.
37.5.
37.5. Yep.
Seriously. Can't
Okay, and on the other side, that would be 17.5 plus x.
Okay.
And so if you push these to the same side, that's 1x, take away 0.75x, so that'd be 0.25x. And if you push this to the other side and subtract your 1750, that would be 20. And then if you took 20 and divided by, isn't that going to be 80? Yes. Okay, so we end up with 80. Okay. Now, could you graph this? Could you take y1 in your calculator and make it x plus 17.5? And y sub 2 in your calculator, which would be 0.75x plus 37.5. Could you graph those? If you could graph those, could you use the calculate intersect feature to help you?
Oh,
sure.
Yeah.
That'd be a great way to double check your work.
Sure.
But this is what's going to give you the credit. So make sure you know how to do your algebra.
Math power.
Okay, now, some problems are going to be better solved with graphing. We'll see what we can do with this. But this is also one you can do with algebra too. Or algebra as well.
Yeah.
So, you've got the situation, find the dimensions of the rectangle with minimum perimeter if its area is 200 square meters. So we will have to do some graphing here. Find this least perimeter. So let's see here. Area, we know the area is length times width. So you've got length. This is one of those situations where they're calling the width x, and they're calling y the length. And since the area is 200, they're just using length times width or x times y, and so they just solved it for y. That's all. If you said x times y equals 200, that's how they came up with this expression.
Okay.
Okay, so now perimeter,
sense.
we know that's 2 lengths plus 2 widths equals your perimeter. Okay, and so 2 of these lengths, so that would be 2 times 200 over x, plus 2 of these widths equals my perimeter. So 400 over x plus 2x equals the perimeter. Okay, now we're going to graph this, so I'm going to jump over on my handy-dandy calculator here. I need to fire that up, so I'll be back.
Come on, hurry up.
All right, so we've got our calculator.
Okay, that's good. That's better.
And we want, what was it? Let me quickly jump back here. And see
Alpha.
400 plus 2x, or 400 over x plus 2x. Okay. So, 400 over x. Ooh, I can use that feature where we do the alpha y equals, so I can use the fraction.
Yeah, alpha y equals
400 over x plus 2x. Now, here's the function we're dealing with, and what would be a good window to use? Well, you can always start with the standard window, but if you do zoom 6, the standard window, I'm going to guess that we're going to get a really ugly picture. Couple things don't make sense. If your area is 200 and you made your, let's say you made one of the dimensions 1, then your area would be 200. So I'm at least going to start with 0 and go to 200. Now this might not be enough. Maybe we want to go by increments of 10 just for kicks and giggles, but 0 to 200, go by increments of 10. So take a look at the scale or the picture. Okay.
Ooh, weird.
Got a weird looking shape on there.
Okay, I promised you I wouldn't do a slant asymptote. Okay, so the reality is right there is an asymptote running through there. It's either a slant asymptote or it's even more ridiculous than that. It could be a parabolic asymptote. Oh wow, I bet it is. We're not talking about that. I think we're going to be focusing our attention down here at the minimum. That's a piece of cake. You could do that.
We need to find, they said minimum perimeter. Minimum perimeter. So if you were doing a minimum perimeter, that would help cut down my cost in fencing if I was going to fence an area like this.
Yep.
Or cut down on my costs on building. If I wanted to keep a particular area, but I just wanted to cut down on the costs of the actual limitations of the outside edges. So we can do the calculate minimum feature.
Yep.
Oops. And it's going to ask for a left bound. I think 1 would work. And, well, of course it would work. I'm not sure why I chose 1. Each one of those marks is 10. I could have chosen 0, I guess. And a right bound, we'll at least go to 30. One that could hardly be written on the screen, so I guess it didn't like that. At least it didn't like drawing it, because it was so close to the edge. It looks like the minimum width would, or the width and the length, here are the dimensions of the width and the length that would cause the minimum perimeter. Now, what is that? Oh, no, I take that back. The minimum width would be the 14.41. The minimum perimeter would be the 56.57. Okay? Because I forgot my y in this particular that we've typed here is the perimeter, whereas my x is my
width.
That's my width, according to my picture. So, and yeah, we didn't do all the algebra. And why didn't we do all the algebra here? Because we didn't have a value for this over here. It was a variable. So we needed to use the calculator for that, okay? All right, so take a look at another situation. A gym charges $100 to join plus $25 per month. Write a function that gives the average monthly cost.
Okay, who is Jim? And why is he charging money? That's what I really want to know.
Costs. So C of x equals 25x plus $100 to join. graph the function. Why is this a difficult thing? Boy, let me check on this one. Stewart Cannery packages tomato juice in 2-liter cylindrical cans. Hold on a second. Yeah, I have no idea how I got the wrong problem putting that last video, but I'll get it fixed. Anyway, so yeah, I guess we can jump back to that one and cross that one off our list, and we will make sure that this is the one we use. Stewart Cannery.
It's a canary.
Packages tomato juice. I didn't even know a canary could do that. Man, there must be one talented bird.
His name's Stewart. Oh, what he's a canary.
Anyway, it's a cannery. I know that, folks. Okay, good bit of dad humor there for you.
Amen.
Packages tomato juice in 2-liter cylindrical cans. Find the radius and the height of the cans if the cans have a surface area of 1,000 square centimeters. So here we want to remind you about formulas for a cylinder. You've got, you obviously have your pi r squared h, and you've got your surface area, which is 2 pi r squared plus 2 pi r h. Now, how do we know that it's a 2-liter can, and how do we know that we could say that it's 2,000 cubic centimeters? Well, if it's a 2-liter can, that's 2,000 units, right?
Right, because there's 1,000 cubic centimeters in one, 1 liter. So that's all we're getting at there.
If you went down to, I think a cubic centimeter is the equivalent of a cubic millimeter or something like that, if I remember correctly.
What? I think I meant milliliter. Maybe I said it right. I don't know.
Oh, yeah. Duh. It would be really easy if you would just read, Mr. Staley.
Yeah.
Anyway, so the surface area formula. So we're combining these two pieces of information. So let's see what we can do with this. Using volume and surface area formulas and that fact, we can conclude these two pieces of information. So can we do anything with this? What do you think? Can we somehow combine these two pieces or two equations together?
Let's see. Is there a common variable that they have in common? Oh, look. Radius. Is he talking? Where'd he go? What happened? Is he just not there?
Well, we sure can. What in the world?
Okay. I'll have to get another video. I'll be right back. Oh, crap. What did I do? Let's see if I can move this while I'm recording a video. Okay. I think I'm back. Anyway. Moving stuff around when I shouldn't be again, so I messed things up. Let's see.
So I noticed that the units of measurement are not the same. They've got liters and then
Glad I figured that out.
square centimeters. So they throw in this fact down here. 1 liter is 1,000 cubic centimeters.
Kind of already established
That helps
didn't
you
we?
out. Yeah, that'll work.
Come on, get to the part where we connect equations together.
Let's just say a rectangular solid.
Can't even hear myself. What's going on?
How would you find the volume of that? Length times width times height. In geometry, we then took that formula and we said, if you take the area of the base and multiply by the height, you get the volume of that object.
Right, that's the old formula for cylinders, right? Volume, pi r squared h.
Right, cylinder can. What's the area of the base?
Man, this is bad audio from the
Pi r
previous
squared,
video.
right? And then we multiply that by the height.
Man, can we fast forward this a little bit? Let's get to the good stuff.
Well, how do you find the surface area?
Okay, I think I went too far.
Take
I said
this formula and let's solve for the height.
okay. So
We know
2,000
that we have 2 liters of fluid.
divided
so
by pi r
we're
squared.
dealing with 2,000 cubic centimeters. How do we solve that for H?
2,000 divided by pi r squared. Come on, move along.
So the big question is, do you know how to deal with multiplication?
Oh, we should be able to do that.
How do we deal with it?
There
So
it
we could
is.
substitute this.
Yes, substitute.
2 pi r squared plus 2, now what?
Oh, I jumped ahead. So
Plus 2 pi r times 2,000 over pi r squared.
we're just taking one equation and plug it into the other equation. Equals 1,000.
1,000.
Yeah. So hopefully you can start seeing some canceling, maybe.
Okay. Now what? Anything cancel out?
Yeah.
Specifically right about in here? Anything canceling out?
Yep, pi. One of the
There's
R's.
a pi. Yeah, we got a pi in the numerator and a pi in the denominator, right?
Amen.
Pi divided by pi is 1.
That's good, whoever that kid was.
One of the radii, right?
One of the radii, yes.
Yeah, you get radii is the plural of radius.
Yes, it is.
Like the plural of Elvis when you go to Las Vegas. Elvi, right?
Elvi, yes.
Exactly.
That's the plural of Elvis. You're right. So
Exactly. Fun fact. Ah, good. So this is really 2 pi r squared plus 4,000 over r
right, 2 times 2,000 would be 4,000.
equals 1,000.
Okay. This makes more sense why it's in this section because it's a
Now,
rational
if you
function.
use the idea of what we talked about in Algebra 2, anything can be divided by 1.
Come on, get this common denominator.
Pressure from the 2.7 video.
Come on, multiply by r.
What is this denominator over here missing
R.
that the other ones have?
R.
Top and bottom. What's this one over here on the far right missing?
R.
Also. And if you multiply the entire equation by that common denominator, what magic happens?
No more denominators. Well, sorry. The denominators are now 1.
Denominators are gone.
No more denominators. That's a lie.
So we end up with 2 pi r squared.
Cubed.
Oh, good catch. Good catch. Thank you so much.
Cubed.
Appreciate.
Good catch, whoever that kid was.
Got to pay attention to how many r's we got.
Yeah, r cubed.
Okay. What if we took this 1,000r and we brought it to the other side?
Do it.
That'd just be minus 1,000r. Plus we got a 4,000.
1,000 r. Where did 100 come from? So you got to catch
Now,
that?
we could try to use synthetic division on that thing, but I'm going to guess it's going to get pretty doggone ugly
Come on,
fast.
right there.
I got a backup plan.
Zero.
Graphing calculator. Don't listen to the factoring person. That'll hurt. And I lost a 0, didn't I?
Yes.
Accidentally. Okay, what was your question?
Why are you multiplying the whole thing by another r?
I just wanted to get rid of the denominators. Now, could I have graphed the... If I knew that I was going to be graphing this doggone thing on a calculator, because it wasn't going to end up being nice, could I have avoided getting common denominators and multiplying through by that common denominator? Sure,
Yes.
I could have avoided
Yep.
that.
Sure.
Because if I'm going to switch right to this thing, because it's not going to work out and be nice, the calculator does a good job of graphing, so I don't have to worry about that.
But if you think, well, this might be, something that's factorable or something that's nice, then possibly we do this kind of work.
Come on, get to the
It's
graph.
obviously reviewed from the other questions. So, why don't you grab the graphing calculator and graph the doggone thing?
Do it.
Now, what are we really looking for?
Where it equals
I
0.
know that you're going to make this thing
X-intercepts.
equal to y1, but what are we really looking for?
X-intercepts. We want to know when it's
I
equal
know
to
we
0.
want the radius, but tell me on the when you graph it on this doggone machine, you're looking for zeros, right? You're looking for when it equals 0.
X-intercepts. Yes.
So these would be x-intercepts of the graph.
Thank you.
Now, do you think a negative radius is something you're looking for?
No. Negative radius?
Do you think a negative
What?
radius is something you're looking for?
No.
No. So if this crosses the x-axis on the negative side,
We don't
what do
care.
you doggone do? I want to know about the positive ones.
Amen.
Go find me the positive ones. Hint, hint. That means I don't need a nice-looking picture. I just need to know where it crosses the x-axis.
Probably quadrant 1, by the way.
Use your calculate 0. I don't want to see any people just using the trace button. Let me use my cursor.
Yeah, calculate
I
0.
want you to use the calculate 0 feature.
Come on, show us the
above
graph on the
the trace
calculator.
button.
Where's it at?
Okay? If you're struggling to enter it, please ask
Where in
for
the
help.
world is he going?
Calculate.
All right, I'm going to see if I can fast forward this and get to a place where we can...
Sure.
Come on. Where's he at? Come on, do we have a graph somewhere? Somewhere. Take it forever.
The other two are positive.
Yeah, well, he's wandering around the room here. Oh, there it is. Gonna graph it finally? Thank heavens. It's taking forever. Okay. Switch to, yeah, switch to
Minus
decimals.
1,000
There we go.
X plus 4,000.
Better change that.
Did you get something like this?
Ugh. I guess we just want to know when it hits
Well,
the x-axis.
To be quite honest, all you saw was something like this.
True.
The reality is that there are 3 zeros. No, you don't need a beautiful picture. You don't need a beautiful picture like this. Okay? Why? Because all you needed to do was tell me where it's crossing the x-axis. And the positive ones are the ones you're interested in.
Yeah,
If you
right over
calculate
here.
0, whoa, don't do that. Stop.
Where's he going with this, man? I can't see it. Yeah, stop. I want to know what that is and what that is.
4.62
There we go. 4.62.
and 9.66.
Yeah, if you round to the hundreds, that's what they are.
4.62, 9.66. Okay? Whoa, that is not. Now, those two places would make the situation happen. You still have 2 liters of volume and only 1,000 square centimeters of surface area. Now, will it change the height if we choose the 4.62 versus the 9.66 radius?
Probably.
I mean, 9.66 radius, we're talking about 19 centimeters. Is that about right?
Wow.
19 centimeters. Something like that.
Divide by 2.54.
Versus a can that has 9 centimeters. Okay,
Okay.
correct. 19 centimeters is fairly wide. A Pringles can is probably about 9 centimeters. Okay, now I want to ask, if you have the same amount of volume, if we choose the radius 4.62 or 9.66, is that going to change the height?
Yeah. It will change the height.
It's going to change the height. Now, what if the grocery store tells me I have to choose? I only am allowed to have this much shelf space.
Okay, yeah.
Maybe they expect to stack 2
the cans on top of each other. That may force me to choose one radius over another.
Okay.
So I may not be the one that's able to dictate that. I may
Right.
have to go with what people tell me,
True.
because they're going to take my product and put it on their store shelves.
Right. I think I'm digressing right now.
Anyway, if you want to find the heights to this question, you would have to plug them in. I
Right.
believe, let's see, the 4.62 creates a 29.8. So this is the radius, and the height would be 29.83.
Wow.
But if this is the radius, then the can is only 6.883 centimeters tall. That's a pretty doggone short can,
Short.
as wide as it is.
Yeah, that they
So,
wouldn't do
It's
that.
probably not the best choice.
No, it would be the first one.
Quite honest.
Nobody wouldn't want that second one. Okay, I think that's enough for this. I don't think there was anything more on this video. Okay, talk to you later. Bye.